All right, this is going to be the iOS SDK primer. The announcements for the week are: don't forget your iOS setup is due is due on the 4th. We've released the staff choice project already. It's Evil Hangman. David went over a little bit. Yes, you can see that I'm really not good at picking up Halloween costumes. And don't forget that next Wednesday, Tommy's doing the walkthrough. There's going to be some useful information that will be helpful for the staff choice offered today, but the bulk of it you'll get from Tommy. Tonight we're going to be going over a few of the iOS templates, and we're also going to be going over Storyboard a lot. Storyboard came about in iOS 5, as David said, and it's really fantastic, especially in terms of dealing with large iOS projects, because as with any large software project, you go away for 3 months and then come back and have to support it. The refamiliarizing yourself stage of trying to figure out where all my interfaces are and how everything fits together is really a lot easier thanks to the magic of Storyboard, where you see the whole project laid out. The downside, if you've got a small monitor, it's going to drive you absolutely nuts. Storyboard is pretty much built for the big cinema displays, but we'll try to get through that as painlessly as possible. So, all right. So the first thing we're going to do is create a new project. Single view. All right. Unlike the examples that David did in class today, we're actually going to use Storyboard so I can explain it. Put that in class. All right. There's a couple useful things that David sort of glossed over a little bit. Ignoring the project build stuff, we're just going to go right to the Storyboard. Let me begin this. All right. So here we've got a few things. We've got this arrow over here, which shows that this is the initial entry point for your for your app as it comes in. And any of these things can be examined from over here on the right in our inspector section. Where is the one that actually? All right, put on the view controller. There we go. This is it. There we go. View controller. One of the things that I wanted to show is right up here you can see your class. So as you create new things, it's going to use like generic UI view controller, and then you can set it to the default of the view controller of your class. This is, as you'll see over the course of this, especially useful. The other thing with this, where is it? Come on, view controller. Here it is initial view. View controller. Next week, the section's going to go over a little bit more in depth of nav controllers and table view controllers, but I'm going to go over it a little bit today. The standard single view single view application is just one view controller. One of the things that's especially useful with Storyboard is the way that you can rapidly prototype and put an app together without actually writing any code. And we're going to go over a little bit of that. First thing we're going to do is we're going to drop a nav controller in. First question is, what the hell is a nav controller? It allows you, if you've got a iOS device, if you go into contacts or email, you'll see tabled apps that you can drill down into, much like I think the simulator has one. If we go into contacts, we can create a couple. So as we drill down, a new view pops onto the stack, and then you're able to back it out. That's in a nutshell what a nav controller is. It's one of the more powerful facets of iOS. The ability to keep a stack of view controllers, much the way you have a stack of activities in Android. But and so what we can do is make this the initial view controller, which takes it away from the default that we have. We throw away the table that's thrown in. Just slap on delete. And then we just have to connect. Now, if you're going to connect, when you're connecting elements in Storyboard, it's all control to the target. And then you can define your segues or relationships. In this case, because it's a nav controller, we're going to define this as the root view controller. It really doesn't change anything from the initial look. It's only subsequently that we're going to see more of this. And again, let me put up the keyboard viewer so you can see. Keyboard viewer, there we go. That's all done by sever the link. By hitting Control, drag, and making the connection. Then you can slap in your UI elements. As David went over, we have some of the standards are the UI text field, UI label, and the UI button. So, nothing all that difficult. We just, there we go. All we did was personalize some of these. You can see what you're doing with the inspectors. We threw up a label, centered it, slapped the name on it, text field, put in the placeholder text, which is text that you'll see before you type into it. Oh, obviously it won't do anything here in the interface builder. And same with the button. The interesting thing with a button is buttons have multiple states. There's a default state, highlighted, selected, or disabled, and you control the title of the button with all those stages. Unlike user UI labels, you don't want to set the text directly because that's going to that will not cause it to resize to be the with the new text. And you can set up a with Storyboard, you can set up a new view controller without writing any code. So for example, if we slap in a new view controller, put it over here, line it up nicely. Yeah, this is what I was talking about where you needed a big monitor to actually see this. Again, if you just do Control, drag, we can set up a segue from one view controller to another view controller without writing a single line of code. Here we're just going to slap on a a label. And let me embiggen this, otherwise I will get yelled at for putting something on the screen that's illegible. And sometimes the view control, the UI elements with Interface Builder are a little difficult to deal with. So we can, we can't even make it bigger. All right, so we'll just do it the old-fashioned way. Change the width. Center. Change the size. Perfect. All right. And then when we run it, we click on the button, we bounce over to the other view controller without writing anything.
You got that back button for free.
Yes, you get that free with the nav controller, which we'll be going over further in class and also in section next week. The nice thing is you can also get a number of different types of segues. And when you click on the segue itself, you can give it a specific identifier and choose what the style is. Like, for example, if we wanted to add a new button, we can also connect to here, and this time make it a modal. With modal, and you'll notice there's a difference. I'm not sure if you can see that. With the two different types of segues, this is a push segue, which works with the nav controller. This is a modal or a pop-up segue, and any of the pop-up segues, you have different types of transitions. They can also be customized within your code, but let's just show you what one of those looks like. And if that wasn't clear, it slid up from the bottom. And the downside is you also have no way of getting rid of it. That's why when we look at the utility template, which we'll go over briefly after this, you define a delegate, and we'll go a little bit more into protocols. But I just wanted to show how simple it was to rapidly prototype with Storyboard. The other thing that you can do, and again, it's they're going to go more into table view controllers, later, but they changed the table view controller with the advent of Storyboard. So there's there it is. The table view controller has two ways of presenting data now. There's dynamic, or the ones that are defined in your code, or you can have static cells. And in this case, we've got one section with, where is it? Where's my? Sorry, I forgot which of the screens there was the definition for how many static cells I had. All right, well, so each of these, the default is custom. You can walk through the various standards for styles. It's all in the wonderful Apple documentation on table view controllers. but we're just going to quickly so rip this off and make a connection from here to here. And with a static table, you don't have to write anything to get static data. And each of the table elements, any of these rows, can also bounce to can be set up to bounce to other view controllers. So it's again, like I said, it's for rapid prototyping. There's nothing like this. So you can work with your design people to show, okay, this is how it would look in a couple hours max for something just showing interactions and connections. And just I find at least where we work, if the designers have something in their hand that they can play with the interactions, they'll come up with a lot more interesting ways to use it than they would if they're flipping through. Sitting in meetings trying to come up with what they're going to do. But let's take a look at some of the there was some stuff that I wanted to show you with protocols and delegates that are going to be especially useful. So let's bounce into the pre-baked code, as David puts it. Let me just show you what it does. And so this does nothing especially useful. It's just label, text field, a button, and what you don't see is actually a web view. And what happens behind the scenes is, well, obviously when I hit carriage return, the keyboard goes away, and then when you hit submit button, we get both all the UI elements are now disabled, so you can't click on them, and what we have is a web view that, because I turned off my internet so that I wouldn't get interrupted in class, stops my web view from actually going to the internet. So the good thing is we can obviously see that all errors then get pushed back to the website. And now let's do it again without inadvertent errors. All right. In a second, I'll have a working internet connection, and all will be right with the world. There you go. Of course.
Did you define the message that popped up there?
No, that's what came back as an error, and we'll go over that right now, and then and this is the question was whether I defined the error text that was put up there, and I didn't. That's the error that is returns from one of the delegate calls, and that can be customized easily. So let's walk through the code a little bit. First, I've got to make it bigger so that people in the cheap seats can see. All the guts of this, there's some in the storyboard, so we'll go over this. Nothing is, the view controller sets is much like we saw in class. We define our UI elements with our outlets and then just point everything around. I'm going to show a forced error that is a standard mistake that a lot of people will make when they're playing with the interface builder for the first time. I know I made it several times, but we'll go over that. So one of the things, and Oops, why is this not? All right. So one of the things is when we want a UI element to have a delegate, you have to connect it. You don't get it for free, even if you've connected the element as an outlet. So as we saw in David's code, where he defined the delegate for the alert view. In my code, I have multiple protocols that I support: UI text field delegate and UI web view delegate. So both of these, you have to define the delegate, or you don't get any of the delegate functions being called. And we'll go over that briefly right now. So let's disconnect everything. So we don't want that. We'll leave the outlets. And another mistake that people often make is they accidentally set up the wrong view. So if we connect this as an outlet back to the view controller as nice. The good news is iOS, this version of the SDK fixed this problem. Because it used to be that it was really easy to disconnect your view and connect it incorrectly, because any UI element, whether it's a web view, a button, or anything, is at its root level of view. So it used to be much easier to accidentally disconnect your view and then connect it incorrectly to the wrong element if you drew that. But it looks like with 4.3.2, possibly 4.3.1, they locked that down a little bit. So the good news is it saves you from the simple error that I was going to make sure that everybody knew how to avoid. All right. So now if you've got if you forget to set up your delegates, and let's turn off Wi-Fi again. Oops. So I hit return on the keyboard, which you can't quite see. So hitting return on the keyboard, not doing anything. Oh, okay, this was cached. But the reason for that was without the delegates, obviously none of the delegate functionality will be called, and we'll see a little bit more in the source code what we did. Much like with David's code, we set up the protocols that we're going to be implementing. We defined our outlets. We defined our actions. Again, as David said, you need IB outlets for anything that's going to be connecting to that will be connecting to Interface Builder, and IB action for anything that the Interface Builder will be calling. I kind of like the naming convention for functions that are connected to button press events to actually say pressed, but that's just a convention. As David went over briefly in class, using the pragma mark gives you sections, which makes it a lot easier to find things in your code. With a 1,000-line program, there's nothing like this shortcut to jump through the files quickly and efficiently. The downside is most people, unlike probably David and myself, don't alphabetize all their methods, but that's just a level of anal retentiveness that most people don't share, I guess. One of the things that I did in this function is David talked briefly about private helper functions, at the beginning by extending the interface. I added some helper methods. If they're not defined here, there's nothing stopping you from writing them in your code. One of the reasons I like to define them this way is you can leverage the IDE to hit you with warnings for your implementation if you've forgotten something that you're going to be using. David said that these could be called from outside your program. I'd have to do some tests, but I think he might be wrong on that. I was pretty sure if you've defined something like this and they can't be seen by the outside world, you're going to get compiler errors from the IDE when you try to call them. The other thing, and David went over it, showed it briefly in class, is when you've connected things to UI elements, you get these little connection points, and if you click on them, you can see where it's connected and what it's connected to. I find that really useful to double sanity check things, especially with large projects. Because if you're playing around in the storyboard, you might have forgotten to connect something, and if it's not connected, you won't see the full circle. You'll just see a circle, as we'll see quickly here. Oops, need to save it. So over here you'll see that it's no longer connected. So it's just yet another way of sanity checking yourself and making sure that you've connected everything, as opposed to wondering why things that you expect to be working suddenly aren't. Because if they're not connected to the nib files, anytime you try to use these elements, they're going to default to nil. Obviously, you can send in any messages you want to nil. It's just obviously you also won't get the responses that you're expecting. Oh, actually, perfect. Sorry, just doing a quick reconnect of everything. And one of the things you'll notice is I reconnected the web view incorrectly, so you can override what's in view. So this should give me the error that I was going to show you earlier. It's just you can't delete the base level view, which they've protected you from. So in our view controller code, there's a couple of useful things that are gonna come in handy for your for your staff choice projects. One of which is the text view delegate, the text field delegate methods. If you take a look at the UI text field delegate, the documentation for that, there's a bunch of useful methods, and it points correctly, which you can use to get the data from a text field. So as you saw in David's Evil Hangman example, he was typing things into a UI text field, and the data was being cleared out of that. These optional protocol methods that will give you access to your UI text field, and with it from that the data that's in there, so that you can pull out your letter one letter at a time. Obviously, you also saw there's also ways to keep the keyboard up at all times, because when there's the resign first responder will get rid of the keyboard, but if you take a look at the UI responder documentation, there's also ways to make a field the first responder, which will keep the keyboard up. Tommy's going to go over more into this, but I'm a big fan of pointing things out to people to read the documentation and get up to speed on. The other thing that's useful, and this is probably going to be more useful for your student choice projects that may or may not connect to the internet, is using the network activity indicator functionality. What that gives you is the little spinner at the status bar at the top of your device or emulator. So we'll go back to the emulator. I'll delete the app. So when I run this, to this actually, and this is the spinning beach ball that we all love that use Apple's products. So this is the one of the things that I had done to create the forced error was connect the web view as the view, and this is much cleaner than it used to be. It used to be that the program would just crap out, and you'd have a fun time trying to figure out what it is. This is basically letting you know that the view's not what it's expecting, and this was forced by making sure that the view controller has an inappropriate view, default view. So once I set that correctly, our app once again runs. And if you look at the top briefly, because Harvard has a really good network connection, there was briefly a spinner up there, and I can change the code to not turn it off to show you what I mean by using it. So this is basically just a quick little indicator to show that you're doing something on the with a network connection, and the standard practice is when one of your calls dies with an error or success, you stop the spinner. One thing that people might find with their code, and it's going to drive them, that's something that will drive you to distraction, is if your HTTP calls are synchronous rather than asynchronous, anything changing the UI elements on that thread are going to hang while that's waiting. So for example, if you set the spinner synchronous HTTP call, and while that's running, you're not going to see any spinners or any elements on your page changing. That's something that I spent a lot of time trying to figure out what I was doing wrong when I was doing stuff for this code beforehand. This class beforehand. But the code which will end up on the website. The other thing I want to show is to show the question, the response to the question about the error condition. This is one of the optional. All these are optional parts of the UI WebView delegate. So if there was an error in the previous example was because we had no connectivity, we get the error. We can pull out the localized description and inject that string into HTML, and then just shove that into load that right into the WebView. This is also another way if you want pretty printed text on a web page, you can just slap it into a web view and force the HTML yourself. A couple of people I know have done, done book apps that used HTML to handle because HTML for free gives you some of the paging and formatting, etc. The other functionality that we have here is, I leveraged these optional calls just to turn on and off the spinner, to give you these indications. The UI text field delegates, you can turn on and off the keyboard. One thing that's pretty much it for our single view application. The next template we're going to look at is the utility template, which gives you the flip application. This is the one that David recommends for the Evil Hangman, and we'll in a second. We'll take a look at that code. So. So even without doing any code in this, we get some useful things. We get, as you see here, we get 2 view controllers, and as when we click on the information, it flips to give us the utility view, and done bounces us right back. The interesting stuff there, and we can take a look at the code. The flip side view controller implements the flip side controller delegate, and I wanted to show briefly how a protocol is written. This is as Apple's really good about giving you sample code that actually gives you a lot of useful information. So you define your protocol with and what happens is anyone that implements this is going to have this method that they have to call. So this is a nice way of having 2 view controllers talk to one another, so that the former will close things properly, blah blah blah. But in your programs, for example, if you had if you're working with, say, Flickr, the photo people, you can have asynchronous HTTP request methods that once they're done, are going to call back to the view controller to give the view controller heads up to display the image that you've just downloaded. So there's lots. The delegate in the protocol is one of the most powerful things in iOS. Because anything can be a delegate of anything else, so you don't have to deal with hierarchy. All you have to do is setting things. And one thing that you can do is, in all these examples, they have one-to-one delegate, but you can have a whole NS array of delegates. So, or NS mutable array of delegates, and have a setter just add to the array, to your NS mutable array, so that when something changes, you walk down the list of all sorts of things that will update. So if you've got, for example, go back to the Flickr app. If you've got 40 little image, individual image views on the screen, using your custom image view controller, once the delegates fire, each of those could get the update to refresh themselves, and each of the things on the screen will update. Or as in David's example from class, if you have a game, you might want multiple, army men in a fighting game to all take actions and move at the same time. So, and this is pretty simple stuff. So the flip side, all it has just right out of the box is a done button that and all it does is call the delegate to say close the modal window. Because as you saw when I did a modal example just using storyboards, without any code changes, once a modal's on the screen, it's on the screen. There's not much you can do with it. This is how you have a modal view dismiss itself. And the parent in the main view, this is simply done by calling dismiss modal view controller, and you can have it either animated or unanimated. And if it's animated, whatever transition brought in the modal is reversed on the way out. Otherwise, it just instantly happens. Sometimes you might want that for, if something else is happening on the screen that's, and but for the most part, I kind of like the animated transitions. The other interesting thing here is to prepare for segue. As we saw on the storyboard, and let me pull that back up so I can show you at the. Any segue between views has a few settings. There's the identifier, which can be used in the code to choose which segue and how it's going to react to it, and the type of segue, whether it's a push in case of navigation controllers, or modal in case of any view controller, and in the case of modal, what the transitions are. And when we look at the code, we can see that in prepare for segue, you can do whatever you want. So in the case of, excuse me, please. In this case, we know that the destination view controller for show alternate supports setting the delegate. A more proper way of doing it, I would check to see whether it supported that, and that can be done this way. think one. Yep. And what this does is, because it's perfectly possible that you're going to have a destination view controller that isn't the flip side view controller, and as such wouldn't have a set delegate. So in the case of multiple, where you've got the possibility of multiple segues, I'm a big fan of always double checking to make sure that you're either check what the view controller is, or checked whether the view controller can respond to this the selector that you're going to send. And why this is a good idea, we can show you with a couple of quick steps. Yeah. So the other interesting thing that you can do with Storyboard, I meant to show it earlier but forgot, is you can slap in tap recognizers. So this whole view now has a tap recognizer. Click on the tap recognizer, change it to 3 taps, and now I can segue from the tap recognizer over to a new view controller. So all right, so now there's no protections. Set delegate just will happen for all segues. So 1, 2, 3, boom. And the reason for that is not clear with the little bit on the screen, but we sent the selector set delegate to a view controller that couldn't handle it, and it threw an exception. So this is one of the reasons why I'm obviously a big fan of double checking everything to make sure it works correctly. But the other thing that showed you is, come on, thank you, is how easy it is to leverage the power of a lot of the UI elements that Apple gives you for free to handle transitions and whatnot. So setting up, you can set up. There's all sorts of gesture recognizers now. It used to be that you had to code all these by hand and guesstimate where and keep track of where everything was, where the fingers were touching on. But now there's set gesture recognizers for everything from taps and slides and swipes and pinches and zooms and the whole rigmarole, which allow you to do a lot of really interesting things. I'm sorry, did you have a question? Okay. And to go back to this to clean things up with the one if statement about whether it responds to the set delegate. It again, this is a modal that we can't get rid of, but it also doesn't blow up. And the selectors are especially useful because, as we've seen in the official protocols, as well as any protocol that we might write ourselves, there's a number of methods in protocols may prove to be optional. So you're never you're never positive that just because something is a member of your implements your protocol, you can't be sure that it will have all the optional elements. So you need to double check to make sure that they're in force. And let's take a look at the baked version of this. And again, it's just showing some more of the UI elements that you have. This is a text view, which is, for the most part, a scrolling label that you can put lots of static text on. You don't have the ability to have colors and whatnot the way that you would with WebView. I added another button, which I'm sure will get yelled at in the videos, of gray on gray is not as clear to see as one would hope. But when it comes up, it segues to a static table. And as I went over briefly before, any static table can be massaged to make it look exactly the way you want it with buttons or whatnot. And in our table view, where is it? There we go. Damn it, I still can't find it. There, in this case, I'm going to blame lack of sleep last night, but inspecting the elements for the table view controller, there is a way to. Here it is. It's under table view controller. You can say how many static fields you have. Table view. Where is it? Here it is. It's under table view select section. It's right over here. And we can see that it's cut off by the screen. But if you look really close, you can see that it actually says 6. Let me move things over on the screen so we can get a video so that I will not get pummeled. So this is how you can control exactly what your static table is going to look like in terms of how many rows, whether you want headers and footers. More information on the table view will be coming up in subsequent lectures and sections, but I'm especially a big fan of the table view because it's so powerful. And the other thing that I was going to go over tonight is the making of a universal app. And it used to be if you're not using Storyboard, it used to be fairly complicated in that you had to have some special code in your app delegate to tell which one it is. But now with the advent of storyboards, it's insanely easy. So a quick project. We're just going to use a single view application. Make it universal. So basically, the only difference between Storyboard for a universal app is which storyboard it goes to. It's got different naming conventions, and these are defined right here in the project target as our main storyboards. There's 2, one for the iPhone and one for the iPad. And so you could conceivably open up, your let's see, the iPhone one. Set up your UI element. Let me change that because it's almost impossible to see that. Change the background color to maybe a nice teal, if that is teal. And then for the iPad, okay, that's way too big. Do pretty much the exact same thing. Oh, one facet of the interface builder, as we just saw, is if you shrink the storyboard so it's easy to see, you can't drop UI elements on top of it because it's no longer proportional. So you can't be sure where you're going to be putting it. So you've got to slap it back up to full size, which is yet another reason why Storyboard loves the cinema display. Let me just change the color here. And because they both use the same view controller, where is it? Because they both use the same view controller, you can have two different storyboards with all point to the same view controller handling the two different models. In some cases, obviously, you're going to want you may want different ones if you want different actions depending on how the data is viewed. But this is one of the more powerful things that Apple's given us. So now from the view controller, hello, thank you. Let me just change this so it actually has something useful on it. Oh, I did it backwards. Oh, they're both text fields, that's why. Yep. Oh, sorry, I thought somebody had a question. All right, so now I've got the button on there. Why did that do that twice? UI button. And much like we always see in this class, anytime you do a live coding demo, there's always going to be a mistake. And then basically all we're going to do is self dot. There we go, title label. So now let's do this. We're going to do this twice. Come on. There we go. people can see it. So we hit iPad press. It changes the name to iPad press. And if we run this on the iPhone, we get iPhone press. So one view controller, two different interfaces, and it took what, 30 seconds? The coding that they put in behind the scenes is really spectacular for what it does for users. I'm sorry, for developers to free up your time and ability to do things. And if we look at what a universal app looks like without the storyboard, it's still fairly straightforward. It's just there's a little bit more going on behind the scenes. So yeah, that works. So again, we've got two nibs. We've got, where is it? It's right here. Let me begin this for you. So the app delegate, which for the most part, as David said in class, you're not going to want to touch. But what we get here is with the app delegate, which is the first place that the I'm sorry, you couldn't see this. This is the app delegate code. This is the first place that your program's going to go. As it did finish launching with options, it sets up the window to the screen, which it knows because it obviously knows whether it's an iPhone or an iPad. It checks to see whether what the user interface idiom is, and that will just do some of the famous hand waving for what that means. But if we looked into what the user interface idiom, I'm pretty sure we're going to have three flavors of iOS devices. There's the iPad, the iPhone, or the Apple TV at the moment, and then the proper nib file is called and expanded. And then from there, it's similar to what we did with the storyboard. All we have to do is set our elements in our nib files, and then connect them to our view controller. So once again, we can have one view controller dealing with two separate nib files. Because the view controller doesn't care if two places look at it. All it worries about is the one that's on the screen at any given time. And that's all handled by, in this case, with nib name, and in our previous case, this was all done with our storyboard defining. The storyboard does the same work that we see here with nib name. It basically pulls out the views from behind the scenes and unpacks them. Because if you actually look at what a nib file is in your terminal, much like the app or a bundle, it's actually a directory of files, and inside there you're going to find XML files that you're never ever going to hand edit, that actually keep track of where things are on the screen, and et cetera, et cetera. So that's pretty much it in a nutshell for some of the stuff I wanted to go over tonight. Obviously, the big thing is when you're playing with the interface builder, take a look at the different objects. There's plenty of example code and documentation on each of the different UI elements and how to use them. We went over a few of the ones that are pretty much the standard ones you're going to be using: text fields, web views, labels, buttons, text views. If you've got a big UI label, There's more for image views, which I didn't get. I'll put up in the sample code, and which is similar to what we saw with the web view putting up an image. An image view can do the same thing, except it's using either data that an image you're pulling down from the internet or an image that you've got within your resource bundle. And actually, let me show you quickly one of those, just because there's a couple things that I want people to know how to do. So let me shrink this, grab an image off my keyboard, that I pulled down earlier. So if you want to drop an image into your project, just take it, drop it into the project. It'll ask you if you want to copy it. That is, unless you've got a special way that you do things at work, where all your images are from one location that's within source control, you're always going to want to copy the item in. Anything that you're going to submit for class, always copy the item in, because unfortunately, if you don't copy the item in, it doesn't go up into the zip file that you send to your grader, and the grader won't be able to compile and run your code. We mark off for that sort of thing. And then you get the image built into your project. I typically create a new group for images called images or something, but that's just me being obsessive compulsive. And in your nib files, you just slap in an image view. You can resize it. There's two ways with your resizing image views, or anything as a view. You can go to the corners and move things around, or you can explicitly set the size. So for example, if I want this to be, we'll say 150. All right. Then with once an image is part of your project, you can just select it and it'll fit in. Here, the modes are, I'll leave these as an exercise to play with yourself. You can choose what you want the image to do based off of its full size to fit within the small, possibly small window that you have, or big window. So if, and that's pretty much how image views work. I just wanted to briefly go over them just because I can't imagine that people's student choice projects or even the staff choice project for the windscreen, you're not going to want to put up an image or something to illustrate how things are to illustrate certain conditions, whether success or failure conditions for the state of play in the game. And that's it for this week. I'm sure there's going to be a lot more coming up next week. If people have questions with iOS, don't hesitate to use the forums. Email your TF or ask. And one thing that not a lot of people did for the Android section, if you're feeling a little overwhelmed, it should be possible to ask for office hours from your TF, or ask for office hours on the forum, and ATF might be able to help you. Just because this class goes really fast, and it's really easy to get overwhelmed and feel that it's your fault. And there is extra help available for people, and we're happy to give it. That's it.